Okay. My name's Jamie McCutcheon. I'm the principal and founder of Rymar Waterworks. We're the manufacturer of the Marley Float Skimmer. And we're going to go through today and try to do a focus on what I understand to be the requirements in Kentucky. We're also going to touch base on some other more simple ways to do skimmer basin design, assuming you may do some work in surrounding states, whether it's Ohio or Tennessee or others. But this is intended to be pretty informal. So if you have a question along the way, please unmute and ask. I'll be glad to try to answer. But we'll run through this, and hopefully you'll find something that you can learn. I'm gonna cut the video off, just that'll help with the recording for people that watch it later. So again, my name's Jamie. I'm a 92 graduate of Clemson with a bachelor's in civil engineering. I had my own engineering company, SedCAD Engineering, from 99 to 2018, and I was acquired by Davis and Floyd at that time, and I'm still working with them. But in 2013, I invented the Marley Float Skimmer and started marketing it. And we rebranded our company as Rymar Waterworks in 2018. I'm a licensed engineer, South Carolina, North Carolina, and Georgia. And basically, I've been doing private development, land development, stormwater related work since really 1992. So I've been doing this for quite a while, and so hopefully I can provide some things that'll be helpful today. So first, we're going to just kind of understand the basics of a skimmer. Some of you may be more familiar, some may not be as familiar, so we'll just go through some very basics to start with. We're going to get into how to model a skimmer and sediment a skimmer basin in SedCAD. Then we're going to go into some more advanced modeling in either Hydraflow or HydroCAD. And that would be if you had to model it for quantity control, whether you have to do that during construction or if you want to consider using the skimmer post-construction. And then we're also going to kind of talk about why you may want to consider using a skimmer for post-construction if you've not done so previously. And then we're going to wrap up with introducing you, or kind of giving you a little heads up on some things we have coming. I'd actually hope they would be done by today, but they're not quite finished. But some testing we're in process right now, and then one other new product we introduced last year. So sediment basins with skimmers are intended to withdraw from the surface, so it meets the EPA requirement for surface withdrawal. The Marley Float Skimmer is a little bit different than others. Most others are directly on the surface, so take in, from the surface itself. Our skimmer takes in from a little bit below the surface, so there is an advantage with that. We have a debris guard around it, and so anything that's floating on the top of the basin, seed like straw or leaves, even diesel fuel, if you had a leak or spill, stays on the surface and does not get discharged through the skimmer. Now, if the pond gets above the riser in the pond, then obviously it would go through, but for the most part, it should stay below the riser during construction. So there are a number of different skimmers on the market. The Faircloth skimmer was the first one to really be out there. I'm sure you're familiar with it. Ours is the Marley Float. Looks a little bit different than most others. We have the erosion supply skimmer, which is very similar to Faircloth, and the IAS skimmer, and there may be others around, but these 3 or 4 are kind of the ones that we see most often. This is from the North Carolina permit, but most states' general construction permit have a requirement for surface withdrawal now. And typically it reads something like this, that sediment basins and traps that receive runoff, maybe 1 acre or more, sometimes it's 5 acres more. So use outlet structures that withdraw water from the surface unless it is infeasible. And generally they say it's very rare that it's infeasible. In some areas, if they have frozen conditions that persist for extended period of time, in that case, it may be infeasible, but it had to be a pretty severe freeze to get down where skimmers were not functioning correctly. So currently there are about 30 states that I'm aware of that have surface withdrawal requirements. The states that are not on this list are in 2 categories. They either have gone beyond that, where some states now don't allow discharge from basins. You actually have to pump it through a treatment system and then discharge it, or they're likely to have a EPA add that to them the next time they renew their permit. One of the biggest things about skimmers that is a misnomer is that they're constant flow devices. Testing has shown that all skimmers do have a change in flow rate with depth, so they have a flow rate curve. Some are more significant than others. They all have to do with the hydraulics of the specific skimmer. But to demonstrate that, this is a chart that was done testing by TRI Environmental. They did this testing for the state of Georgia when they were updating their erosion control manual. And see on the right here, there's 3 different 3-inch skimmers. And this chart goes from 0 to 4 feet of depth. And so you can see down at a 1 foot depth, 2 of them are pretty close, around 37 gallons per minute. And one is about double that at 70. And then all 3 skimmers have about a 25% increase in flow rate from 1 to 4 feet of depth. And again, 2 of them are fairly close, 47 to 53. And one again is nearly double at 90. So the point is, if you simply say a 3-inch skimmer, you may not get what you're expected to get out of that. And so it's important to recognize the difference in flow rate between different skimmers. Again, just to kind of point that out, this is a flow rate curve chart for our 2-inch to 4-inch skimmers in each orifice configuration. You can see they all have at least a slight increase from 0 to 4 feet. Our 4-inch skimmer has a more pronounced increase. It goes from, well, at a foot of depth, it's about 140 GPM up to a little over 170 GPM at 4 feet. So it's interesting to kind of look at different states and what criteria they have for their sediment basins. There's some consistencies throughout. And for those of you in Kentucky, you have kind of the odd man out requirements here for, at least in this chart. So most states have a basin volume that's required of somewhere between 1,800 cubic feet to 3,600 cubic feet. Ohio has a volume that's 1,800 cubic feet of dewatering zone, plus an additional 1,000 cubic feet of per acre disturbed area that's below the invert. So it's a permanent storage area in the pond. So basically a wet sediment basin. Whereas in Kentucky, they do require you to calculate it based on your soil type that you have on site. I'm not going to get into the detail of that in this webinar. I'm going to assume those of you in that area, you kind of have that understanding already, but if we need to, we can certainly talk about it. Surface area, again, most states have a required surface area, 325 square feet per CFS for North Carolina, South Carolina. Georgia bases it on the 2-year storm and flow rate. And if you run the math, it's about the same as the North and South Carolina one. Ohio doesn't specify. They say they don't want a basin over 5 feet deep, so it keeps that surface area larger. And again, Kentucky requires you to calculate it based on your soil type and your basin ratio. Principal spillway, that's going to be, in this case, typically the skimmer and then the top of the riser, if you do have a riser structure in the basin. So it kind of varies between the 2-year, 10-year storm, depending on which state you're in. And again, most states require emergency spillway, and that varies from as low as the 10-year storm in North Carolina to the 100-year in South Carolina, with most other states looking at like a 25-year storm during construction. They don't make it go as far as the 100. As far as skimmers being required, that varies from typically 10 acres to down to as small as 1 acre in North Carolina. In Kentucky, it's required on any sediment basin. And so generally a sediment basin is required for 5 acres or larger. The difference in a sediment basin and sediment trap obviously is a outlet structure. Sediment traps typically have just a stone outlet versus a basin has more of a structure, or at least a pipe and skimmer. But typically, if you're doing a basin for even as small as 1 or 2 acres, you would put in a skimmer in its place. And then dewatering time is one that also varies. Most states have a range of 2 to 5, or in Ohio, 2 to 7 days. Georgia doesn't specify at all. They just leave it up to the engineer. And Kentucky, again, requires you to just calculate it for 80% trapping, which is probably good because you're going to see as we get into SedCAD, you can achieve 80% trapping in less than 2 days, depending on your soil types. But in most cases, you can do that. So you can actually not have to hold the water there quite as long. So So the simplified version of basin design is going to just be a volume and dewatering time. So we have a Excel tool. We actually have two Excel tools on our website. One just is for a dry basin, and the other one is for a wet basin. So it calculates the sediment storage volume that's needed in places such as Ohio versus just the required dewatering volume. Most of our tool also have in this area here a way to calculate your required dewatering volume if you have a standard volume per cubic feet per acre. And again, Kentucky, you're trying to calculate that, but what we're trying to do here is to highlight that you need to use your skimmer size based on your required volume, not necessarily the full volume in your pond, especially if your pond's going to be converted to a detention basin post-construction. It may have much more volume in it than is required for sediment control. So you're going to have, basically your date, your project name, location, engineering company, and again, your description over here. And we got two other lines you can put in some more information. And then here are your inputs. So you'll end up putting a minimum or maximum time to drain. Now, again, if you're having to calculate this, you're not using this tool, but if you're in other states, we recommend a range of 2 to 5 days. Your pond depth is going to be the depth controlled by your skimmer to get to that required volume. So if your basin's 6 feet deep and your top of your riser is at 5 feet, but you hit your required volume at 3 feet, you just put in a 3-foot depth. Your top length and width and bottom length and width, again, we know there are almost no basins that are rectangular or square. So just use your engineering judgment to modify these to get to a reasonable length and width, and then to calculate your pond volume. And we typically try to get that within about 5% of what your required is. And so, we're at 61.2 in this example required, and we're at 61.6, so pretty close in there. So when you do that, our tool will calculate the drawdown rate or time for each skimmer with each orifice configuration. And then down here at the bottom, you're going to see a skimmer report page tab. So if you click on that tab, it'll take you to this nice, neat one-page report printout. And so at the top of the page, you're going to see all of the information you put in. So it's going to have your company, date, project, etc. It's going to have here highlighted the calculated pond volume or required pond volume for dewatering, and the calculated, so the reviewer can quickly check and see that you're close on that. And it's going to calculate your minimum flow rate for your maximum time and your maximum flow rate for your minimum time, again specifying that range of time that you're allowing. And then because it is our tool, we're going to give you the drawdown time for each model and each orifice. And then based on the range that you specified, we'll tell you which skimmers fit within that range. And then you can pick, from whichever ones fall within that range, which one you'd prefer on site. So in this example, you could go as small as our 3-inch with a 3-inch orifice, but it's going to push it out to, a little bit over 4 days to drain that basin. We typically try to shoot for around that 72-hour. So in this case, I would probably recommend our 4-inch with a 3.5-inch orifice to get down around 68 hours. But if you're, want to get the water out as fast as you can, if you've got, say, soils that are more sandy and you don't need as much time, you could jump all the way up to our 6-inch skimmer with a 4-inch orifice and drain it in just over 2 days, assuming that you've got that 2-day minimum time frame. We also have sediment basin details available on our website. These are free to download and modify as needed. They're in PDF and CAD. We establish in these your minimum length to width ratio, and if you have a maximum, again, if you have a minimum volume required and surface area requirements. But here's the key thing is the minimum dewatering time and maximum dewatering time. Go ahead and establish those on your detail. And so when it's reviewed, that is approved. And then in the data block, you've got, the information you need. So your total drainage area, your disturbed area, again, going to each basin, your flow rate that you're basing your basin design on, whether that's the 2-year, 10-year storm. Again, basin volume, you want to show that your required is your provided is at least as much as required. and your surface area, the same thing, that you provided at least as much as required. Basic outlet information, skimmer size. Most skimmers have a size and an orifice that you'll specify. And then we put in here for skimmer manufacturer so that you can say, hey, I based it on this manufacturer's flow rates. Is an equal allowed? Yes or no? Now, most of the time this is going to be yes. And you'll have, there may be some instances where you say no, but I mean, in most cases it's going to be yes. And again, here you specify in your flow rate range. And so if a contractor wants to substitute, a Marley for another, or say a Faircloth for a Marley, then as long as that skimmer flow rate is within that range, it's a simple shop drawing, type submittal. It's not a full redesign of the basin. And hopefully that speeds things up, because obviously the skimmers are one of the first things to go in the pond. So we have these details. This one is for a temporary sediment trap, just has a pipe going through it. And then we also have one with a riser as well, such as this. And then we also have versions that have a permanent, pool for sediment storage that is below your invert. So this is for the permanent pool version, just has a couple of extra things, has the sediment storage volume required here, and then has a sediment storage block to make sure that you've met your requirements there. Basically, everything else is pretty much the same, though, between the ones without a permanent pool and with. So that is the very basics of skimmer modeling. If anyone has any questions on that, please let me know. But if not,
Jamie.
Yes.
This is Travis at Mendel Scott here with Megan.
Yeah.
What's the difference between the skimmer size and the orifice? So I guess that's the pipe that goes down to your culvert or whatever.
So I'll show you in a little bit on the detail. But most skimmers have like a general opening or a size, and that size generally is similar to the pipe, but not always. And then they have an orifice. So in ours, we provide an orifice plate, and I'll show you this in a little bit, that has specific sizes already established, and we've tested each one of those. The Faircloth and maybe the Ocean Supply, I'm not sure how it does it, has a little plug that the contractor is supposed to cut to a required opening. So you may have say a 4-inch skimmer with, in ours, it would either be a 2.5, 3.5 inch orifice that you could add to it, and reduce it from 4 inches. Or like for the Faircloth, they have a plug and you can cut it down to within 1/10 of an inch, supposedly, to try to hit a more precise flow rate. But again, that flow rate that they're based on is calculated based on an orifice flow and not a tested. So there's been shown to be some differences there, but that's why you have the orifice, because you may have a skimmer but want a smaller orifice to reduce the flow down, and it just allows the skimmers to provide a wider range of flow rates.
Okay, thank you.
So we're going to jump into modeling in SedCAD, and I believe, and those in Kentucky tell me if I'm wrong, that this is fairly common as far as what you're required to do, is to calculate the trapping efficiency. So we're going to go through the basics of it. So this is a site that we did in Greenville County, South Carolina. And it was an existing facility, had a warehouse and some truck areas, and they wanted to add an additional warehouse here on the backside. So they had enough area to try to do that. So here's the proposed design, a new building, new trucking. Here's the new basin that some of the existing site water as well as all the new site waters go into, and this basin was being used as a sediment basin during construction. So, we had a disturbed area of about just under 3.5 acres, but we had a total watershed of a little over 10 acres going to this basin. So we had to factor in, additional flow through it during construction. So this was our design. We're showing our baffles, had our skimmer specified there. as far as going in. So when we had to model that in SedCAD, at least here we're using a type 2 storm, 10-year, 24-hour event. In this case, for that area, rainfall depth for that is about 5.5 inches. We also plugged in our soil type. So in this case, it was a Cecil soils, pretty common here. And this was our particle size distribution that we plugged into SedCAD to help calculate the sedimentology. So then we put in our network and routing. So we kept this pretty simple. We had our on-site disturbed area, 3.1 acres, and then off, either off-site or undisturbed of 7.4 coming in. We put in a curve number of 86 for the disturbed area. That was based on a bare earth conditions for clay soil here. And then the 69 was kind of a composite for the undeveloped area offsite and developed on-site. Then we put in our K factors, which is your soil erodibility based on your soil type on site. Your C factor, again, this was bare earth for the disturbed area, and then 0.05 for the undisturbed. And then your P factor, again, typically that's a 1 as a worst case scenario. And then we checked our disturbed, for our disturbed area, left it unchecked for the offsite area. So most time, if you've got baffles in, you can reduce your dead space to 0. We left it as 20, just being a little more conservative in this case. And then we built our basin. So we had our contour, elevation area table here that we're going to build into our model. In this case, we had a little bit of a sediment storage area underneath, had about a 1/2 foot, but we really didn't put that so much into the model. So the big thing when you're building your pond and doing your elevation area table, you're going to have this stage increment setting over here, and we recommend you set that to 0.10. And what that'll do is it'll give you a place to plug in your skimmer flow. So, you build your elevation area table, just, plugging those numbers in off your design. Then you're going to set up your outlet structure. So, your primary outlet, you're going to have that enhanced perforated riser. I know SedCAD came out with that change. Well, it's been quite a few years now, but anyway, they realized there were some issues with the standard riser, so upgraded to enhanced. And then instead of an orifice at the bottom, which is what we used to do, or I think SedCAD has like some other option for like a skimmer discharge or something. And I forget exactly what it is. It's been a long time since I've used it, but we recommend you use the user input discharge. So you put that as your second outlet. But before you do that, you put in your riser information. So in this case, our riser is 7 feet tall, put our barrel length, slope, spillway elevation, etc. So then here we go. So then you go to your user input discharge. And when you do that, it'll come up with this table, and you just fill in this table with the discharge rate at each elevation. Now, I had you set it at 0.10. You do not have to interpolate every single one of these. SedCAD will do that for you. So if you look at our detail, and let's say you want to, which skimmer you're going to try. And so you'll plug in the flow rate and off of this table and this little clearer version of the table. So, our skimmer has the standard 4-inch skimmer with no orifice, or 3.5, 3, 2.5, or 2-inch orifice that it can provide. And we provide the third-party tested verified flow rate at 0.1, 0.3, 0.5, and then every 1/2 foot up to 4 feet. So you just take the numbers off the table and plug here in your spillway discharge. And again, SedCAD will calculate in between. So if you have a basin depth that's greater than 4 feet, our test tank, or our TRI's test tank was only 4 feet deep. So that's our limit. You can either maintain that. So in this case, we just set it at 0.383, going on out. Or if you really want to get a little more detailed, you can go back and use that design tool that we showed you to start with and plug in a pond depth a little deeper. So say your pond 6 feet deep. Well, then just looking at the 4-inch skimmer with a 4-inch orifice, it calculates the flow rate, from basically 0 to 6 feet deep then. So if you wanted to plug it in at these additional depths, you could go pull that off. At a 4-foot depth, it's running about 0.38, 0.39 CFS. And if you go up to 6, it's getting up to 0.41. So there's a slight increase. So if you really want to get more accurate, you can, or you can just kind of extrapolate it out. So then, once you run your report and look at your structure details, it's going to give you all the information. Just kind of check and make sure it's put in there correctly. And again, this case, we barely hit our 80%. So we got our 80.1%. So check the box. Our sediment basin's good to meet the permit requirements there. We had a dewatering time of 1.5 days. In South Carolina, the requirement is supposed to be 2 to 5 days. But in Greenville County, where we did this project, their standard's actually 1 to 3 days, which is a little different than the state. But typically what we've seen is that is not much of a concern if you've got it that you're hitting your 80%. So they don't look at the dewatering time quite as much, but at least this does tell you, what the dewatering time is. The other thing to keep into account, if you look at your sediment graph, SedCAD does not take into account the surface withdrawal effect. So I've actually talked to Pam Schwab about this some, and they confirmed that SedCAD assumes water's coming through the entire water column from top to bottom. And so let's say you're working on a site and you get up and you're at 77, 78% trapping, and it's just not hitting that 80, the magic number to get your permit. We've had some luck, depends on the reviewer and the agency, obviously. We've had some luck in explaining how SedCAD calculates this and saying it would be reasonable, in our professional opinion, that we would get a couple of percent higher trapping through the surface withdrawal impact. And we've had some occasions where reviewers will agree with that, and we don't have to expanding the pond or tinkering and trial and error to hit that magic 80%. Not sure if that'll work in your specific area with your specific MS4, but it may be worth trying if you're having trouble getting the numbers to churn out like you need. Again, we met it in here. You can try other skimmer sizes. One thing that we found is sometimes actually putting in a bigger skimmer can actually help, especially if your water's getting over your riser, because that higher flow rate, again, SedCAD doesn't take into account that it's coming over the riser. It assumes it's going through the whole water column. So sometimes that kicks you to a higher number. But anyway, you have to tinker with it from time to time, as I'm sure you're aware. Any questions on modeling in SedCAD? That was kind of quick. So, okay. You've probably seen some skimmers installed, but in case you haven't, got a couple of pictures here, things just to be aware of. So this is a basin, essentially one of our older model skimmers, but anyway, it was obviously newly constructed, just put in, had first rain after installation. It looks okay. The baffles are in, slopes are tracked. Obviously haven't seeded and strawed it yet and gotten any vegetation. One thing to point out here is this stone pad. The way the contractor put this in, he graded everything and then put the stone in. And so by doing that, you're going to have a 6 to 8 inch volume of water staying in this basin pretty much all the time. And so it's going to be hard to get it dry and hard to get it to actually get vegetation established, especially in this area right around the outlet. So we recommend that they actually grade that out and set the skimmer down as far as you can. Now, in this case, it looks like the outlet structure inverts actually maybe 3 or 4 inches above the bottom of the pond anyway. So having a little extra sediment storage doesn't hurt, especially right around there. But just something to note on your details and plans, to call out for, to depress that skimmer pit to kind of get the water to come to it and keep a little small wet area versus, having the whole bottom of the basin stay wet. We've seen some really poor installations. This is our prime example how not to install a skimmer. There's no flexible coupling here. I'm not sure how they even have it connected there. If you look on the side, they actually have this valve open, so water's bypassing and going here anyway if they did have it connected properly. Obviously the pipe's not near long enough. That pipe needs to be about 1.5 times the height of the outlet structure so that the skimmer can rise up and water doesn't come over above it. Anyway, lots of things that the contractor did wrong here. On our new model, we've seen a couple of times where they actually been installed incorrectly. This one, they twisted it upside down. I'm sure how they managed to do that, but obviously they didn't install the pipe long enough. Several different things they did wrong here. So we do the best we can with our instructions and trying to train contractors, but it is something to look for, and hopefully only do it this way one time. We learn after that. And then skimmers are not maintenance free. This is one that was on a project that we did the engineering on, and you can see vegetation growing up out of the skimmer. There's probably a problem. In this case, you can see, sediment's gotten under the pipe and it's kind of lifting the pipe up. This definitely needs some maintenance, but that root ball was blocking the skimmer and causing this pond to hold water much longer than it was intended. They finally got it opened up and pulled like a 8-inch root ball out of the skimmer. So we'll jump in for a minute about permanent use of skimmers. So I don't know if any of you have considered using skimmers permanently, but we're going to go through a couple of reasons why you may want to do that. So this is one case study that shows how skimmers can help with maintenance. So this pond was in Simpsonville, South Carolina. It was at an old car dealership and probably had not been maintained in 15 to 20 years. It was a very large pond, about 3/4 of an acre to an acre, and very deep. It's like a 25, 30 foot deep with like 1.5 to 1 side slopes. So when we got here, we helped the owners get it brought back into compliance. Basically had to get guys out there to harvest timber out of it and get it cleaned out. And when we did that, we noticed that something didn't look right because it was holding water and had these orifices here that you can see kind of through the limbs, but it didn't have a low flow orifice. And so we did some more investigating and found out that underneath this, you can kind of see it on this picture on the far right, 6 feet below what is now the bottom of the basin is a 2-inch orifice that had obviously gotten clogged and had caused 6 feet of muck and debris to accumulate in this pond over however many years it had been. So this was going to be extraordinarily expensive to fix. Like I said, the pond was severe slopes. They're going to have to cut in a road just to get down to it and muck it out. So we got with the county and redesigned the basin. And when we did that, we closed up these orifices, moved some up higher. The pond actually had some extra volume available, but the county wanted a 2-inch orifice back in the bottom. And the owner was very concerned, obviously, about how hard that would be to maintain. I mean, it's hard to tell from this picture, but that's about a 8 to 10 feet height there. And remember, there's 6 feet down below. So if you had to get in this outlet structure to try to get down and unclog something would be very dangerous. Plus water is out into the pond a fair amount. So if water was up here, you'd be 20 feet away just trying to get there. So anyway, we convinced the county to let us put in a skimmer as a pilot project and monitor it to make sure it was working. So these are pictures from our monitoring. You see the amount of trash and debris that's in there, but the skimmer continues to drain. The contractor installed it a little bit above the bottom of the pond. I wish they put it a little, all the way down, but in any event, it would infiltrate over time. So we had about a year later, the owner was now maintaining the pond, and they had landscapers out, and they cut all the vegetation on the side slopes, but had not pulled it all out. And that afternoon got a huge rain, about 5 inches of rain in just a couple of hours. And all the trash and debris got washed down into the pond. And you can see our skimmer here with all these sticks and leaves and everything in there around it, but it did manage to drain. Had it been clogged, it would have been easy, just pull the rope, and the rope doesn't show up well here, but it does have a rope on it, pull over to the side and get to it. But if the skimmer had not been there and had to get into the pond and unclog that 2-inch outlet, that would have been a major nightmare and very dangerous to do it. So just showing the benefits of skimmer not clogging and easier to maintain. We had another site in Charlotte, North Carolina, similar situation. The client received a notice that the county or city was going to do an inspection of their pond. And to be honest, they didn't know they had a pond. This was so grown up that they didn't realize there was a pond there. They asked us to come find their pond. We did. We cleaned off the emergency spillway. we finally found this head wall. The sediment was basically up all the way to the top of this head wall. And so it was hidden. We just saw a little, trickle kind of, being sucked down in the ground. Figured it had to be some sort of outlet there. So we cleaned this out, got it functioning again, put a riprap ring around it to try to protect it. But it was in a natural area and a live stream. And so every time it rained, you got all this leaf litter, tree debris and trash you can see from the bottles and stuff that would clog this pond up. And sometimes it would really clog and stay clogged for weeks. And, that head wall is about 6 feet underwater. So just getting to it and getting it unclogged is a major challenge. So we got with the client and said, hey, let's redesign your pond. Let's help you with this maintenance issue because it's costing them several $1,000s a year just to try to keep it maintained. And what we're going to do in the process, City of Charlotte has a stormwater utility fee that's about $2,000 per acre per year. And they also have a stormwater utility credit program. So we said, we're going to redesign this pond and we're going to maximize your fee credit in the process. And so we put in an outlet structure, riser, and then we put in a skimmer. And that was a challenge because the City of Charlotte's design manual said point blank, skimmers cannot be used for post-construction. And they put that in when they were familiar with the Faircloth and the PVC model. So we actually had to go meet with the City of Charlotte, take them our skimmer, let them beat on it, see that it's a HDP product, very durable, UV resistant. And they've said, okay, you can use that permanently. So we did. So designed the site to do that. And in doing so, we got them a 95% stormwater fee credit, which was equivalent to about $25,000 a year savings. So they paid for all of this design work and construction work in, I think, a 1.5 to 2 year time frame, maybe just over 2 years. Got their money back for what we did. And so we monitored that. This was our older model skimmer that was in place. Again, it was a live stream area. So when it would rain, it would take a little while to drain down. Some big rains, water got up to the top of the riser and had a lot of trash. We had to kind of keep that cleaned off. One thing we noticed was we put in an HDPE pipe between the skimmer and the riser. And over time, that pipe bowed. Now, this is probably 3 years after the skimmer had been in place. So you see a bow in here from the HDPE. It just, when it gets warmer, it bows. And then just this past year, or in August of this year, we replaced the skimmer with our newest model skimmer. And so it does a little better job of keeping the debris out. Plus it sits down in the water, doesn't twist. And we've got it in place and we're monitoring it now. The flow rates are very close, so we didn't have to redesign anything. But this is our new skimmer in place. You can see it is accumulating quite a bit of sediment. We're probably gonna have to clean the sediment out next year. But it's been about 6 years or so since the skimmer's been in. So over that time, a fair amount of sediment's accumulated. But again, no major maintenance issues. If it does, and we hadn't tied the rope to this yet, but you just pull the rope over the side, clean the skimmer off, push it back out. Much easier to get to and maintain than having to get to that orifice down, under several feet of water. So if you're going to use a skimmer permanently, you got to understand how to model that in Hydraflow or HydroCAD or whatever hydrology program you're going to do for your pre versus post calculations. So we're going to run through a quick example of a simple site, relatively simple site, on how to model a skimmer in Hydraflow. So this is about a 5-acre site. So we had a pre-development watershed, and then we had a post-developed disturbed area to a sediment basin. And then we had the rest of that area that was going to our study point. And so this is the site plan. So we had, again, just over 5 acres, almost 6 acres total area. About 2 1/4 here is being disturbed, going to a small sediment basin. And then this other area is undisturbed, and it's going to the study point over here. The study point is across a road, a little small side road. And so we were trying to contain quantity during construction just so we didn't create any additional liability there, even though we are creating somewhat of a point source. Pretty much everything was flowing down to this point anyway before crossing the road. So again, our about 5.5 acres, curve number 59, time of concentration was just under 20 minutes. In our type 2 storm. Post development for our disturbed portion, again, we're using a curve number of 86 for during construction bare soils, time concentration down to about 7 minutes. The rest of the post construction was the same as pre because it didn't change. So again, we're building in our stage storage charts. We got our elevation and our contour area. And you'll see here, we built in the 0.1, 0.3, 0.5, like we did in SedCAD. And so unfortunately, that does require you to interpolate your contour area at those elevations. We just kind of got close. We may not go to the nth degree here, but get close enough to build that storage in there. And again, you're going to pull off the skimmer what the flow rate is. So when you build your outlet structure, you're going to have your A, which again is your barrel going out. So in this case, 18-inch pipe. This was a complicated riser for a small pond. So it had a 6-inch orifice at just under 2 feet, 1.75 feet above the bottom. The riser was 3.6 feet tall and had a rectangular 1-foot weir 3 feet above the bottom of the pond. And for our skimmer flow, and this is where you're kind of the trick is you have this user-defined column in Hydraflow. And so at each stage, we plug in our user-defined flow from our detail. So from 0 to 4 feet deep, plug that in. And again, if you're over 4 feet deep, you can extrapolate. This pond happened to be 4 feet deep, so we didn't have to do it on this, but you can just use an average or kind of use a flow rate curve. Again, you can, if you want to get detailed, you can go back and use our tool and it'll calculate it for you. And so then if you're looking at your schematic in Hydraflow, normally you see a low flow orifice down here at the bottom. In this case, you're not seeing that, again, because we have our user defined, but there's our 6-inch weir, there's our rectangular weir and top of the riser. And then if you look at your stage discharge curve, even though we don't have an orifice, we are getting flow right away. So this little section here is our skimmer flow. And just to kind of demonstrate that, that's the green line there is just that outlet, that user defined flow. So you can see it's a pretty small percentage of the flow, especially once the other riser, rectangular weir and the top of the riser kick in. And if you just want to double check that, once you run it, look at your table, the total flow, up until we hit a depth of 2 feet, the total flow is equal to the user defined. So that's our skimmer. And then the other orifices, weirs, riser, etc., start to kick in. So in this case, we had a 2-year storm. Our pre was 2.3 CFS. Our post was almost 2.5, 2.48. So we had about a 0.15 increase in flow for our 2-year storm. But on our 10-year storm, we had a half a CFS decrease. So it went from 9.5 down to 9. And so the city was okay with allowing a very, very minor increase for the 2. We're reducing the 10. We had run SedCAD on this and calculated our traffic efficiency to be over 80%. So we checked all the boxes for the pond during construction for quantity control as well as sediment control. So any questions on Hydraflow? I'm assuming that most of you probably use Hydraflow since it's built into Civil 3D now. Okay. The other program that we've used is HydroCAD. HydroCAD is very similar to Hydraflow. There are just a couple of differences. One, I like it because the reports are smaller. With electronic submittals now, it's not as big deal, but when wasn't that long ago, you had to print out and bind hundreds of pages. So if you could save the volume of paper, it's kind of nice to do that. But HydroCAD's also a smaller company. They're more receptive to putting in proprietary products. So they have a component of special and user-defined outlets. And so when you build your basins or build your model here, you're going to have your watershed, then you're going to have your basin. We put in the riser structure, and then in this case, we put in this Marley as part of the outlet. Well, to do that, we select a user special or user defined outlet. And then you go, when you have that, it'll come up with this dialog box and you click this load from file. When you do that, it'll go to a folder that has multiple folders of proprietary products, the Marley Float being one of them. And then if you go into the Marley Float folder, it'll have all of our skimmers with all of our orifice configurations in there for you to pick from. So you just pick the one you want to try, hit OK, open, and boom, it puts it into the model for you. So you don't have to type in all those flow rates. So it makes it a little quicker to do trial and error to see which ones are going to hit your magic numbers, and also keep you from doing any typos, because these are tedious to type them in. Oops, go back. It does, I want to point out, you can hit a checkbox to extrapolate. And so if you want it to extrapolate it over 4 feet, it'll do that. You can also do discharge multiplier. So if you wanted to say, hey, I want to do 2 6-inch skimmers, just hit that button. Okay, I'm gonna try 2 of them or 3 of them or whatever it is. If you want to go that route instead of having to put them in as 2 separate outlets. If you need to check your time span, again, if you have an area that is trying to make sure you meet a certain time frame for drawdown, fairly easy to do. The first thing you'd have to do is under your calculation settings, change your time span range. By default, this is going to stop at like 24 hours. You have to push it on out to, in this case, we pushed out to 5 days, 120 hours. And then you just right click on your basin, go to that node report, and it'll pull up a bunch of information. So in this case, we looked at the hydrograph and could see, how far it went out. And then we also looked at the table, could see how, basically about 60, 65 hours, 66 hours, the basin's drained out. So just a couple of easy ways to do to check your timing if that's required. So that gets us through the technical side. Any questions before I move into a little more detail about our products in specifically? Like most engineers, you're a quiet bunch, so I understand. This is our website, rymarwaterworks.com. We're very proud of our website. We think it's one of the better ones in the industry. We've worked hard to make it very useful. So when you go to our website, if you go to buy product and then Marley Float, it'll come up and there's a designs or Marley Float spec sheet page. Here's where we have the tools that you're going to need. So we have our design tool. So we have the Excel tool. We have the one with the permanent pool option in it. We have a comparison chart. So if you want to say, hey, how does the Marley compare to Faircloth with different skimmer sizes? That's there for you. We have all of our skimmers. We have a detail in PDF, detail in CAD. The CAD file is very editable as you need. And we also have our cut sheet or installation instructions. If you scroll down this page is where you'll also find the skimmer basins I talked about earlier. Again, they're in PDF or CAD. Edit as you see fit. There's no login, sign up. There's no locks on any of that. We do have some locks on the design tool so they don't mess with the design criteria, but all those should be very easy to use and download. No sign up or login or anything required. A couple of things about our detail. I mentioned earlier the Orifice Plate when we had the question about the orifice sizes. So this is our 4-inch skimmer. So our 2, 3, and 4 come with one plate like this. And so by default, this is a 4-inch skimmer, but you use this plate. If you zoom in here, you'll see that's a 3.5, 3, 2.5, and 2-inch orifice. And so that simply goes inside the skimmer. And I'll show you a video here in just a second how that works. Again, all of our skimmers have our flow rate for each orifice configuration, and all those again are third-party tested to verify. All of our skimmers come with this flexible coupling. So if you're familiar with like a Fernco style coupling, except we have bellows in it to promote it to be flexible. So this will bend at least 90 degrees, probably really closer to 135 degrees. Very simple to install. So it's just a couple of pipe clamps. We do recommend you put some screws in it just to help hold on. In summer, slick PVC against slick rubber could pull out. We haven't really seen that happen, but we just provide that as a safety mechanism. Our skimmers come weighted. So this bottom section here, you see in the top profile, either side of the orifice has stone ballast in each side of the skimmer to make sure the skimmers stay down. As you see, our orifice and this entire pipe are below the water level. So once the skimmer starts flowing, pipe gets a little angle, that pipe is probably only 10 to 20% full of water. So the air is very buoyant, wants to lift the skimmer up out of the water. And to counteract that, we provide the ballast to do it, but then also to make sure it doesn't sink, we've got a float on top to keep it, level and at the right elevation. Again, our product's made of HDPE, so the floats are polyethylene. It comes up with polyethylene pipe. There are a couple of PVC parts that are hard to get in HDPE, but they're all Schedule 80, so a heavier grade of PVC if they are. And there's no moving parts or anything to get stuck. It is very UV resistant, very, very durable product. Again, we have a shielded orifice, so we have this kind of debris guard or skirt around the outside. So the water is intended to come below this. When the skimmer's sitting on the bottom of the basin, water can go through or seep under, but this is really not intended for flow through it as much as flow under it, so that we trap anything on the surface. It will continue to work in what I'll say mild frozen conditions. You probably have to have 4 to 6 inches of ice to really affect it. Here's where we talk about the orifice. So this little video, hopefully this comes through. You can see, take that orifice plate out, twist it, get it to the right size. Then we have this little metal piece here. My technical term is a nub. And so that nub, goes over as a hole in the middle, but it makes sure that the orifice is perfectly centered over the outlet pipe. And again, we try to label those so the contractor knows what size they are. This is our 2-inch. So it's got a 3/4 inch, 1.5 inch, 1 inch, and 1/2 inch orifices in it. Each of our models has 3 to 5 different orifice configurations. There's 6 models to choose from. And again, all of our orifices have been third-party tested. So a few years ago, last year we redesigned our skimmer. Before that, the skimmer's weight was in the top. And so we did have some issues with it wanting to twist or tip over, especially if it was in a dry basin just sitting out there for a long time. We've redesigned it. It's always now level, so it's self-leveling. As soon as any water gets in, the float comes up. The skimmer body itself pivots, but hopefully none of them ever go through what Aaron's doing to it in the test tank there, but just to show you it's always going to right itself. We had to make a custom float for our large skimmers. So our 6 and 8-inch skimmers have this very large custom float. We built in handles to it to make it a little easier to carry. Again, we're trying to hold a 6-inch pipe underwater, could be as long as a 20-foot pipe. So a lot of buoyancy there. So it weighs about 200 pounds to keep that, below water surface. If you want to use this permanently and you don't like the orange, we have our 6-inch comes in orange, our 8-inch comes in black. So if you're out in the field and ever see the large one, you can tell if it's a 6 or 8 just by the orange or black. But if you want a custom color, let's say you're going to put it, let's put it at University of Louisville and they want red out in the pond. Just let us know. We need some lead time, but we could have a red skimmer float made for you if you needed to. So again, we have 6 models. So they range from our 2-inch with a 1/2 inch orifice is a trickle, 250 cubic feet per day. I mean, that is minuscule flow. So we have, again, 4 options in our 2-inch, or excuse me, 5 options in our 2-inch, 4 in our 3-inch, 5 options in our 4-inch, and our 6, and our 8. Our standard 8 uses a 6-inch pipe to connect the skimmer to the outlet structure. This is so we can reduce the weight some. We do have an option for our 8-inch with an 8-inch pipe. We sometimes refer to that as our 8-inch max. You notice the flow rate here is approaching 2 CFS. That's nearly double what an 8-inch Faircloth flows. Now that's because we are sinking we have a little more head on ours because it's taken from below surface. And just the configuration of the system allows that higher flow. So if you have a really large basin and you're having to put 2 other skimmers, you can really make it simple and save some money by going with our 8-inch max. This is our older retail. We have had to go up on our pricing slightly, like everybody with the supply issues we're having right now and demand. We've had to have a slight increase, but still our 8-inch max is it's just slightly more than an 8-inch Faircloth with double the flow rate. And our 8-inch standard 8-inch is still about 1,000 below a 8-inch Faircloth. And it has even our standard 8-inch at 1.5 CFS has a higher flow rate available. again, all of ours are built into HydroCAD if you have the latest update. So we've talked maybe to a few of you recently about, or previously about doing some testing for TSS. So we're actually just finished this week the testing, and we're waiting on the results of the lab right now. But this is a prototype we've had in a basin. This is that same basin we showed initially as our case study. So we went out, we changed the skimmer to our new model, and we put in this filter system. So this filter, the outer filter is a woven, more of a screen, and then the inner is a non-woven material. It helps with, both of these help remove TSS. The inner is also treated to treat bacteria. It'll also absorb hydrocarbons. We're working to see if it can affect with metals. And then, you know, what we're really hoping is to find a solution for phosphorus and nitrogen, but we haven't gotten there yet. But what we have some ideas we can help with that if you need to. But again, this has been in the field since, I think we put it out there February, March of this year, and we've been monitoring it pretty regular basis. We've got, put it in March. Got a time-lapse camera out there to keep an eye on it. This was like during the spring, heavy pollen season, so really junky stuff in the pond, but you know, it's filtering that out. One thing that we didn't expect was this summer it started to grow vegetation. So this was photo in July, starting to see a little vegetation grow in the non-woven material. And then by August, it was sprouting pretty good. We've been monitoring this, and it has not affected our flow rate. And we are thinking that may actually help with nitrogen phosphorus removal. Not sure how much it'll get done with this fairly limited time, contact time, but it could help some. And then, you know, if you can see this, I know with this kind of picture, it's hard to see, but, you know, pretty turbid water in the basin. But if you look at the outlet, and this is the pipe outlet coming out, fairly clear water coming out. So just visual inspection, we know we're reducing TSS that's leaving the basin. And again, we've got some testing going on right now to prove exactly what TSS we're removing. And we are doing that to an ASTM standard and to a standard that generally complies with the NJCAT standard. And so hopefully if we, we'll be at a point by first of next year to have a ASTM confirmed standard that we can hit. Our goal is 90% TSS, but we'll kind of see where the testing comes out. So lastly, I want to talk about one other Rymar product. So we debuted this last year as well. It's called our Withdrawal, HS for hard surface model. So I'm not sure what you use in your specific area for inlet protection. This is one of the erosion eels, filled with like a chopped up rubber. Unfortunately, these are fairly common, but they don't really do much filtering. They're more flow diverters. And if they get hit by a vehicle, they're toast. You end up with a real mess. So we had a couple of projects where they were using these, and they had long downhill runs, and the water was bypassing the boxes, going to the low point and blowing out the low point. And one place caused some really severe damage. It was like a 30-foot slope, and that entire slope got washed out, I believe, twice because of that. So we came up with this idea. So this is our Withdrawal. It is foam filled. It has a strip. We use either plastic or wood, whichever one's most cost effective at the time, to screw it down into the asphalt. This is intended for that time where you've got that interim asphalt phase. Most areas seem when they do subdivisions, they leave off the final surface. So once the subdivision is complete, they got a nice, finished product to drive on. But during construction, or that time period, you've got a lip. And so what happens is the water just bypasses the boxes don't work correctly. So you can see here, these two pictures, it does a good job of trapping some sediment, creates a little eddy there. But this little video shows how this is just after rain. Water's coming down the curb line. You can see most of it's on the asphalt. So it's just going to bypass this box if this isn't here, but it hits our wattle, the wattle traps some sediment and then kicks the water over the curb into the box so the box functions properly. And then the biggest advantage of it is it holds up. So it's designed to be driven over. So when it's not raining, it lays down. So even if it's like a sports car, you know, you're not going to hit like one of those asphalt humps or something and knock out your front end. So it handles that. But even if you put a dump truck to it, it can handle it. So this is one of our very first prototypes. It was in the field for well over a year, high traffic area. You can see it's been out there for a while. Sediment's accumulated here. We purposely, there's a catch basin. You can't see it because of the trucks, but there's a catch basin on the other side of the road. We did not put one there. And if you look downhill, you can see how much sediment's made it past that one to go down. So, but anyway, you kind of get a feel for the benefit that can provide. We have applied to Kentucky DOT for approval. What we found is these things are not, there's not really a QPL for most of these. And if they're on a non-state road, if it's not a DOT project, there's not really a requirement in most cases. So it's just up to the engineer. So if you'd like to try those, the details for it are also on our website. So that is it. Wrapping up, if you would like to receive a PDH certificate, if you'll just simply email us at info@rymarwaterworks.com. That will go to myself and to Barbara, and we'll be glad to email you back a PDH. I know some of you may have multiple people you know, in the office watching at once. That's fine. You know, whoever needs one, just email us. And then if you had anyone, I'm going to stop recording right now.